In this video, we are going to understand the Newton's laws of motion. Let's first understand what is Newton's first law of motion. Newton's first law of motion states that a body continues in its state of rest, or in uniform motion in a straight line, unless it is acted upon by an unbalanced force. So let's say, a ball kept on ground, it will continue to its state of rest, unless some force is applied on it. Or, let's take the example of desk at your home. It will be at its state of rest, unless we move the desk by applying some kind of force. Let's understand it in detail. Suppose a block having mass m is kept on ground. So it will be acted upon by force of gravity in the downward direction. Now just think, if the block is acted upon by only one force, that is force of gravity, how the block is still at rest. As the net force appears to be the force of gravity, it should have continued to move towards center of the earth. So, what is that resulting force that cancels out the force of gravity and stop the block from moving to the core of the earth? Ground must be providing the counteracting force which is in opposite direction of force of gravity. This force is called the normal force. Here, there is no normal force on the block as the block is in the air. So the block will fall in the downward direction due to force of gravity. Now let's say, a ball is moving with constant velocity, so as per Newton's first law of motion, a ball will remain in motion unless a net force is acted on it. Now, you will say practically that doesn't happen actually. When we kick the ball, after some time ball gets stop. Let us understand it in detail. Imagine a block is resting on the ground. Here force of gravity is balanced by normal force. So the block is at rest. And now, force is applied to the block. Since the block is acted upon by net force, it should be moved and continue to move. And that doesn't happen. It is due to the force of friction that opposes the applied force. Let us understand the net force. Here, if the applied force is 5 Newton and the force of friction is 3 Newton, then the net force shall be 5 minus 3, that is, 2 Newton. Initially moving body comes to rest because they are being acted by unbalanced force. Here in this case, force of friction is unbalanced force. Let's say, an object is moving with constant velocity and let's assume there is no gravitational interaction. If the net force on the body is 0, velocity will not change. How does net force affects the constant velocity? Let's learn that in Newton's second law of motion. Newton's second law of motion states that the acceleration of an object as produced by a net force is directly proportional to the magnitude of the net force, in the same direction as the net force, and inversely proportional to the object's mass. So, force is equal to multiplication of mass and acceleration. If the net force is applied to an object, we are going to have net acceleration in the direction of force. Here, let's say that net force of 20 Newton is applied on block of mass 5, then force is equal to mass times the acceleration. Here, force is 20 kilograms meters per second square. Mass is 5 kilograms. So acceleration would be 20 divided by 5, that is 4 meter per second square. Now let's say if we double the force to 40 Newton. So the force is mass times the acceleration. So 40 kilograms meter per second square is equal to 5 kilograms into acceleration. So acceleration would be 8 meter per second square. Therefore when we have doubled the force, the acceleration has also doubled. So acceleration is directly proportional to the force. Now let's say, if we double the mass to 10 kilograms and see what happens. Here the force is mass times the acceleration. So 40 kilograms meter per second square is equal to 10 kilograms into acceleration. Here, we have increased the mass from 5 kilograms to 10 kilograms. So the acceleration would be 4 meter per second square as against the 8 meter per second square. So, when we have increased the mass, acceleration has reduced. So, acceleration is inversely proportional to the mass. Here, in this case, let's say there are two forces 40 Newton and 20 Newton applied on the block. So how to calculate acceleration in this case? Here, we need to calculate the net force and then calculate the acceleration due to net force. So force is equal to the mass times the acceleration. So force would be 40 Newton minus 20 Newton kg meter per second square is equal to the 5 kilograms into acceleration. So acceleration would be 4 meter per second square. Let's understand the Newton's third law of motion. Newton's third law of motion states that, to every action, there is always equal and opposite reaction. What does that mean? Let's say there is force and there is equal and opposite reaction. Does one force cancels by equal and opposite reaction? The answer is no. Most important thing to note here is that the both forces acts on different objects. Imagine a block is placed on ice. Here we taking ice as it will have minimum friction. And then if we pushed the block to right with some net force, the block will also exert equal and opposite force. Let's take another example. Suppose you are pushing a desk in your home. The desk will exert equal and opposite force and same can be felt as your hands will get compressed. You can feel the pressure. Let's take another example how the rocket works. In the rocket, combustion takes place in the combustion chamber and then it pushes off the gases with very high velocity from back of the rocket and so each of the particle gets accelerated with very high velocity. As per Newton's third law of motion, there will be equal and opposite reaction on the rocket by the expelling gases. So due to that force on the rocket by the expelling gases, the rocket gets accelerated ahead in the opposite direction of the gases' acceleration.
8, 7, 6, 4, 3, 2, 1, and liftoff of Space Shuttle Atlantis, a final visit to enhance the vision of Hubble into the deepest grandeur of our universe.
Bypass across the board, Scooter, no action.
Houston now controlling, Atlantis on its way. Atlantis on its way, all three engines now throttling down as the vehicle passes through the area of maximum dynamic pressure.
Subscribe Extra Class Academy for more educational content.